Hi students, I am V. Kavita, Assistant Professor in Physics. I did Applied Physics. Okay. Today we discuss in your first unit in Applied Physics, wave optics. Okay. In Applied Physics, we have five units. In that 5 units, first unit is wave optics. In that wave optics, we have three topics: interference, diffraction, polarization. So in wave optics, we have three lessons: interference, diffraction, and polarization. Generally, light has dual nature. Light has dual nature, particle and wave nature. Light has particle and wave nature. So light has particle nature is proved by photoelectric effect, Compton effect. Photoelectric effect, Compton effect. The particle nature of the light proved by these phenomena. But light has also wave nature. So light has dual nature, that means particle and wave nature. Wave nature of light is proved by interference and diffraction phenomena. Okay, wave nature of the light is proved by interference and diffraction phenomena. In general, we have two types of waves, but light has which type of wave? We prove using polarization. So generally, we have two types of waves: transverse wave and longitudinal waves. Here, polarization proves that light has transverse wave nature. Light has transverse wave nature. So, light has particle and wave nature. So, wave nature is proved by interference, diffraction phenomena, and light has a transverse wave nature is proved by polarization. So, in this lesson, we we know what is interference, what is diffraction, what is polarization. We know in this wave optics these three phenomena. In physics, physical optics or wave optics, both are same, is a branch of optics that studied interference, diffraction, polarization, and other phenomena for which the ray approximation of geometric optics is not valid. Geometric optics, where phenomena are not valid, those phenomena we discuss using wave optics. In this wave optics, first phenomena, interference. So we are going to about interference. Let us recall some of the basic definitions. These definitions are already you learned in the previous classes. So again we recall those definitions. First, simply definitions. Reflection. When a ray of light approaches a smooth polished surface and the light ray bounces back. See here, when light ray incident on the surface, that light ray bounces back. It is called the reflection. So light ray incident and come back. So this is called the reflection. Next, refraction. Refraction is the bending of wave when it enters a medium where its speed is different. So this speed difference means velocity changes from fast medium to slow medium, from medium to denser medium. So when light incident on the denser medium, it travels through the medium and bends towards the normal. This is the normal. So this bends towards the normal. Another definition, optical path. So the path that light takes in traveling in an optical medium or system is often called the optical path. Okay, so light travels. This is the medium or a system that light travels through that medium. The path of that light travel in that medium is called optical path. Wavelength. Wavelength is the distance between identical points or distance between two crests or two troughs. Two crests, the distance between two crests or two troughs is called the wavelength. These are definitions already you know, but once again we recall when we are going to discuss wave optics. Okay, frequency, the number of waves that pass a fixed point in a time in unit time. So the number of waves are the number of cycles passed to unit time. See in these two diagrams. Here in the first diagram, take more number of cycles in same time, but here less number of cycles. So this is a high frequency, this is a low frequency because taking more cycles. Amplitude, the maximum distance displacement of the wave. So this is the displacement of the wave. The maximum displacement is called the amplitude. Next, phase difference. The phase difference is the difference in the phase angle of the two waves. See here, these are the two waves propagate simultaneously. Here, see here, the same point, same position. The difference between two waves in this same point is called the phase angle. Path difference. Path difference is the difference the path traversed by the wave. See here, the light waves travel in this path and another light will travel in this path. These two waves, the difference between these two waves is called the path difference. Coherence. The two waves have the same frequency, same wavelength, or fixed constant phase difference, or phase difference is constant, then we call they are in coherence. Coherence means having the same frequency, wavelength, amplitude, and phase difference is constant between those two waves is called in coherence. Coherences are of two types, spatial coherence and temporal coherence. Temporal coherence. Okay. Coherence taken corresponding points. That means if you consider two points on the same wave, our consideration points are we take on the same wave, then we call that coherence is called temporal coherence. If we take the points are two waves, phase relation with another wave is called the spatial coherence. So temporal coherence and spatial coherence. Next definition, monochromatic source. A light source emitting one color of light. Only one color. See here, this is a laser light. This laser light has only green color. That means one color it has only one color. That means it has only one wavelength. If the source have only one wavelength, then that source is called, that light is called monochromatic. But white light is not a monochromatic because it has seven colors. Seven color mixing is the white light. So it is not a monochromatic source. Then we go to interference. Finally, we go to interference. Interference. Principle of superposition of the waves. First, we know what is the principle of superposition of the waves. When two or more waves travel simultaneously in a medium, the resultant displacement at any point is due to algebraic sum of the individual waves. This is the principle of superposition of the waves. Okay? When two or more waves travel simultaneously in a medium, the resultant displacement at any point is due to R. So, superposition point. From that superposition point, the displacement changes as individual displacement, sum of the in algebraic sum of the individual displacement. Here we take two individual displacement y1 and y2. The resultant displacement of that superposition point is y1 plus or minus y2. When displacement changes, amplitude changes, then intensity changes. Because when displacement changes, why displacement changes? When two waves superimpose, when two waves superimpose, when two waves superimpose, the displacement changes as algebraic sum of the individual displacement. That is the principle of superposition. When displacement changes, amplitude changes because amplitude is the maximum displacement of the wave. When this amplitude changes, intensity changes because the amplitude and intensity directly proportional to, that's why intensity changes. Anyway, the modification in the distribution of intensity in the ratio of superposition is known as interference. Modification in the distribution of intensity in the ratio of superposition. When the two waves superimpose, the intensity changes as maxima and minima. The intensity changes as maxima and minima. So that is called the interference. Interference means modification in the intensity. How it is modified? Maxima intensity and minima intensity. Equal width of intensity distribution takes place. Constructive interference. Constructive interference means if the resultant amplitude is the sum of the amplitude of the waves, then the interference is constructive interference. When constructive interference takes place, the two light waves superimpose in phase. The two light waves superimpose in phase. Then the two waves are in coherence. Then interference takes place. That interference is called the constructive interference. When two waves superimpose out of phase, then the resultant amplitude, the resultant displacement is if the resultant amplitude is the difference of the amplitudes of the two waves, then the interference is said destructive interference. Intensity variations are studied as interference patterns are bright and dark fringes. The variation of the interferences take intensities we see in the form of fringes. Condition for interference. What is the condition for interference? The two light sources emitting light waves should be coherent. Light waves are coherent. Separation between two sources should be small. The distance between two sources and the screen should be large. The background should be dark. The source should be narrow and monochromatic. So these are the conditions for interference. If there, if there, is, there is interference, compulsory the two light sources coming from two slits are in coherence. Two slits, the distance between two slits, we take small. Distance between screen, we obtain the pattern, interference pattern on the screen, that the screen from slits to screen, we take very large distance. Background should be dark and source should be narrow and monochromatic. This is the general example for interference. So see this diagram. Soap bubble, sunlight falls on that soap bubble. Interference takes place. Color, rainbow colors obtained. Color lines and rainbow colors obtained because of the interference on that soap bubble from the source of